Look at this next example here where there are two absolute value signs, okay? So in the previous question we did a question with one absolute value sign. So absolute value of 2x plus 1 equals 3x minus 2. We did two questions like that, right? So we said that 2x plus 1 would be positive 3x minus 2, and we set up another equation, 2x plus 1 equals the negative bracket 3x minus 2. We solved them both and we checked our solutions, right? Because really, but in this type, and this is what I don't want to do, where you've got two absolute value signs and absolute value of that plus that equals that, you've got four cases. Both positive, right, down here, both positive, can you see that? The first one positive, the second one negative, right? The third case would be the first one negative, which is down here, the second one positive, and the fourth case would be both negative. Now that is four cases that you need to do. So let's say you decided to do that, both positive, you get an answer, and then you have to check each answer. Now look how long this goes on for. We are not going to do it this way. So first case, both positive. Get an answer, check it. Yes, it's a solution. Case 2, the first one's positive, second one's negative. Get an answer, check it, not a solution. Case 3, the first one looks to be negative, the second one positive. Get a solution, check it, not a solution. And the fourth one, case 4, both negative, right? Get an answer, check it, is a solution, right? Takes forever. So this is what I'm going to do. I'm not going to do this question. I'm not going to do the question that way. I'm going to do this same question another way. Okay, so I'm going to do the same question as the example. That way you can see the example done that way. But I am going to do it another way, okay? Using what we learnt in our very first lessons on absolute values about regions and cases. Okay, example from the textbook, but we're not going to use the textbook method. We're going to go back and look at what we did about 2 weeks ago on absolute value. Remember we looked at the critical points when we had more than one absolute value? We looked at the critical points. You tell me what the critical points are. What makes in here 0? X is negative 1. And over here, what makes 2x minus 3 equal to 0? X is 3 on 2. So that's what we're doing. We know that our critical points, when the values of either one of these will go from positive to negative, are around the points negative 1 and 1.5, which is 3 on 2. We're just going to do 3 regions, region 1, region 2, region 3. Okay? So case 1 is when x is less than, I'm going to put or equal to, okay? Less than or equal to negative 1. Okay, so let's choose a value, and that's, remember we've either got to write this out as it is or put a negative in front of it. So let's look at some values of x less than or equal to negative 1. For example, x is negative 2. Would this thing in this absolute value sign be positive or negative if x was negative 2? It's negative. You'd get negative 7. So this is negative. So negative bracket 2x minus 3. So now what we're going to do is rewrite the equation without absolute value signs, but we need to state whether it's going to be positive or negative. One's if x was less than negative 1. For example, if x is less than, if x was negative 2, wouldn't this second one be negative as well? So I go minus x plus 1 equals 9. I now solve this. Minus 2x minus 3. Minus x minus 1 equals 9, so I've got minus 3x minus plus 3. Good. So I've got minus 3x, that would be plus 2, so over the other side minus 2. So minus 3x equals 7, is that what we're getting? Don't know what this big line down the middle is from. Okay, and therefore x equals 7 over negative 3, or negative 2 1/3. Now, is that in the region of x is less than or equal to negative 1? Does that fit in there, in that domain? Yes, it does. If x is less than or equal to negative 1, well, negative 2/3, negative 2 1/3 is less than or equal to negative 1. It's a solution. It fits in there. See, this case is for all values of x that are less than or equal to negative 1. Now, if my answer here was x equals positive 7, it's not a solution. See, it doesn't fit. But x equals negative 2 1/3 is down here. It's in that in where I've defined that case to be. So I don't have to substitute. So therefore x equals -2 1/3 is a solution. Because it's here. -2 1/3 is there. Do you get that? It's in that range of, in that domain of values of x is less than, as long as your answer here is less than or equal to -1, then it's a solution. So if I would have got x equals +2 here, that does not lie in the values. See, my answers have to be less than or equal to -1, and my answer is less than or equal to -1. It's less than -1, so it's a solution. Case 2, do you remember what we did before? Is from which values of x? From -1 to 3 on 2. -1 less than or equal to x less than or equal to 3 on 2. Now, as long as my answer, when I do set this up, my answer has to lie between -1 and 1.5. And if it does, it's a solution. If it doesn't, it's not a solution. No substitution required. Okay, so what have we got? So we go into the original equation. Let's just choose a value of x. What's a good value to choose? 0. 0 lies between -1 and 1.5. Choose the easiest. So if x was 0, would the first thing be positive or negative? Negative. The second one, positive. So I've got, negative bracket 2x minus 3 plus x plus 1 equals 9. Negative 2x plus 3 plus x plus 1 equals 9. Negative 2x plus x, that's negative x equals, this looks like 9 minus 4 is 5. X is -5. I can see. Is that in that? Does -5 lie between -1 and, so not a solution? All good? Much better if you can understand this method. Case 3. See, x equals -5 does not lie between those values of x. Case 3 is up there. Looks like x is greater than or equal to 3 over 2. Do you see the 3 regions I've got defined between those points? So x is greater than or equal to 3 over 2. Let's just have a quick look. First one, something like, what's bigger than 1.5? Say 2. First one, positive or negative, if x was 2. And that's positive. So that's your plus scenario. Now notice one of the scenarios didn't come up. Like, there really are 4 scenarios that are possible. Because you could go plus, minus, plus, minus, plus. But it doesn't, one of them's not necessary when you use this method. Okay? So I get 2x minus 3 plus x plus 1 equals 9. I've got 3x minus 2 equals 9. 3x is 7. X is 7 over 3, which happens to be 2 1/3. Is 2 1/3, does that fit in any values of x greater than 1.5? I'm allowed to have a, so as long as my solution is greater than or equal to 1.5, it's a solution. X equals 7 over 3. That's 2 1/3. Does lie there. Look, I'm allowed to have values of x. Oh, sorry. Even better. Fits in even better. 11 over 3. So I'm allowed to have values of x greater than or equal to 1.5. Well, 11 over 3 is 3 2/3. It's over here. It lies in there. So that, which is, so x equals 11 over 3 is a solution. Much quicker than the 2 pages, full pages of working that I showed you. So we're going to practice this. Now, let's go and check their answers. So we've got 2 solutions, 11 over 3, which is 3 2/3, and -2 1/3. So you'll just go, therefore, x is -2 1/3, and I don't know, whatever that is. What was it? 3 2/3, or whatever it is. Okay? Of solving this type. When you've got absolute value equals absolute value, if you were to try all the different scenarios, they actually double up, and some of the scenarios are exactly the same. So I'm going to go both positive first. So I'm just going to go case 1 where they're both positive. 3, 8. But if we're going to use this method without defining the range of x values that we've got, right? I'm not putting, this is not critical points method. I'll do critical points in a minute. But with this type, it's probably easier not to use critical points. Okay, so I could have that they're both positive, right? And then I can solve that. And I get that A equals -10. But if I'm going to use this method where they're both positive, so in this case, I'm doing positive, positive, right? That, and I'm just going to show over here that that is exactly the same as doing them both negative, because I could have negative bracket 3a plus 1 equals negative bracket 2a minus 9. And if I just decide to, swap, I get 2a plus 9 equals 2a minus 9 equals 3a plus 1. It's the same as what I was just doing. So I don't need to do this other minus. Do you get it? This is not needed. I don't have to do it. It's identical to that. Plus, plus, or if I want to do minus, minus, and once I swap sides, they're the same. Not needed, right? So A is -10, but I have to check my solution. So A is -10, what would that give me? 3 times -10 is -33 plus 1. Remember, when you're checking, it must be in the original equation. 2 times -10 minus 9, what have we got? -30 plus 1, absolute value of -29, which happens to be 29. And this is -20 minus 9, absolute value of -29, which happens to be 29. This is a solution. A equals 10 is a solution, right? I don't need to do minus, minus. When we've got absolute value of 3a plus 1, sorry, I'm just going to rewrite the question. So we've basically looked at plus, plus, and we didn't need to do minus, minus because it's the same, right? Now we're going to do a plus, minus. So let's go plus on the left. 3a plus 1 equals -2a minus 9. So here I'm doing the plus, minus. I'm just going to call it case 2. My a's look like 9s. So I've got 3a plus 1 equals -2a plus 9. I've got 5a equals 8. A equals 8 over 5. I'm going to have to check that as a solution. So checking, I've got 3 times 8 over 5 plus 1 equals absolute value of 2 times 8 over 5 minus 9. What's that? 24 over 5 plus 1. 5 and 5/5, I think. 5 and 4/5. This is 40 over 5. Oh no, 16 over 5. What's that? 16. 5 and 1/3 minus 9. You can work them out on the calc. Negative something. So, if you do both sides there, if you don't want to use a calculator here, you would just go 24 over 5 plus 5 over 5. Isn't that 29 over 5? And this would be 16 over 5 minus 45 over 5. You can write them both as fractions with a denominator of 5. So therefore A equals 8 over 5 is a solution. This is actually identical to doing minus plus. So I can go negative of 3a plus 1 equals the positive of this one, which is 2a minus 9. And if I decide to swap sides, I've got the negative of 2a minus 9 equals positive 3a plus 1, which is the scenario I started with here. So you don't need to do minus plus. It's the same. Not needed. Okay? So with absolute value equals absolute value, I think we should stick with this method. Okay? So let's just write a little summary. For absolute value equals absolute value, to solve those, use plus plus and then just plus minus and check. I'll just go x, absolute value of x equals absolute value of, or whatever. You wouldn't really do it with y, but absolute value of something equals absolute value of something else. Use plus plus and plus minus and check. is saying to solve absolute value of 4t minus 3 plus absolute value of t minus 1 equals 11. Hence, they want you to plot these solutions on the number line and hence solve this inequality type. Okay? Now, this question, unless you want to do plus plus, minus minus, plus minus, minus plus, check every single solution when you've got the two absolute values on the left in the form of an equation equals something else, use your cases and critical points. And by doing that, you can actually solve part B straight away without doing anything fancy as well. So let's just solve part A. So let's look at our critical points, and what are they? 1 and 3/4. Yep, I've definitely got them far away from each other, but it doesn't matter. Yeah, it is 3/4, isn't it? Yeah. So I've got case 1, case 2, case 3. So case 1 is for values of x less than or equal to 3/4. As I said, t is less than or equal to 3/4. We're going to try t is 0. This first thing would be negative. This would also be negative. So we've got negative of that minus this is 11. Negative 4t plus 3 minus t plus 1 is 11. Negative 5t equals 11 minus 4. So it's 7 over negative 5 or negative 7 over 5, which is negative 1 2/5. Now, does that fit in this range of values? As long as I get an answer that's less than 3/4, do I have an answer less than or equal to 3/4? Ladies, is my answer less than 3/4? Yes, so it is a solution. See, as long as my values are less than 3/4, and negative 1 2/5 is less than 3/4, so therefore t equals negative 1 2/5 is a solution. Now, still same thing, case 2. T lies between 3/4 and 1. So t lies between 3/4 and 1. Okay, give me an example of something lying between 3/4. You're going to have to try, like, I don't mind, just do like 0.9 or something. You can do 7/8. 7/8. See, 3/4 is 6/8. 7/8 is good. So we're going to use 7/8. All right, just pretend there's a 7 over 8 here. What would happen? 7 over 2, that's 3.5. This would be positive. This would be negative. So positive and negative. So I've got 4t minus 3 minus t minus 1 equals 11. So positive minus t plus 1 is 11. We've got 3t minus 2 is 11. 3t is, so that's plus 2, that's 13. T is 13 over 3, which is bigger than 4, isn't it? 4 1/3. Does that fit between 3/4 and 1? No. No solution. No checking required. Case 3 would be t greater than or equal to 1. All right, going back to your original. If t was 2, would this be positive or negative? Positive. T was 2, this would be positive. So it's the plus plus scenario. So we've got 4t minus 3 plus t minus 1 equals 11. And we just solved that one. We've got 3t minus 4 equals 11. So this is plus 4, which is 15. T is 5. Yes, 5t. Sorry, 5t. T is 3. Got it? T is 3. Does that fit? Yes. So therefore, yeah, because as long as t is greater than or equal to 1, yes, t is 3. That's greater than or equal to 1. Therefore, t equals 3 is a solution. So my solutions are to solve the actual equation, which I'm writing out, has solutions of t is negative 1 2/5 and 3. I have two solutions.
Minus 1 of 11.
Typo. Not a typo, a righto. Right, anyway, that equation has two solutions, okay? Now, in the next part, we're supposed to solve it with an inequality. We've just solved part A, okay? We've solved that, and our two solutions are t is negative 1 2/5 and t is 3. They're our two solutions to that. It then says, by plotting the solutions on the number line, I'm going to show you a totally different way of doing this in a minute, but it says by plotting the solutions on the number line and looking at values in between the solutions, solve this with an inequality, okay? In part B, I have to solve absolute value of 4t minus 3 plus absolute value of t minus 1 is less than 11. So what it said, by plotting the solutions on the number line and looking at the values between these solutions, solve this. See, when you're solving an inequality, your answer is not just t equals negative 1 2/5 and t equals 3. It's got to be a range of values. Now, again, let's try a value here, a value in between there, and a value in between here. Okay? So, we've got, if x or t was something like a value here, what value of t could I use? Negative 2? Let's try it. If t is negative 2, so I'm going to try in region 1. For example, if t is negative 2, that's just an example. What would I get? Absolute value of negative 11 plus absolute value of negative 3 is less than 11. Is this true? 11 plus 3. 14 is less than 11. Is that true? No. So in other words, t is less than negative 1 2/5 is not a solution. Right. Let's try in region 2. Give me any value between negative 1 2/5 and 3. We're going to try t is 0. So what I'm really doing, I know I've chosen t is negative 2, but I'm really trying the domain t is less than negative 1 2/5. That's what I'm really doing. In the next one, I'm really trying values of t between negative 1 2/5 and 3. But in my head, I'm doing t is 0. Do you get it? So, I'm just choosing t is 0, for example. What do I get with this? Negative 3 plus absolute value of negative 1. Is that less than 11? Yes, I get 4. So this is true. Oh, geez, I'm sort of running out of a bit of room. 1 minute. To solve this absolute value plus that one is less than 11, so I just go less than, you know, between the values, not including them, because it's a less than inequality. So an example of t greater than 3, I might try t equals 4. Let me try t equals 4 here. What do I get? 16 minus 3, 13, plus absolute value of 3 is less than 11. Well, that's 16 is less than 11. That's not true. So therefore, I have one solution. That I don't write t equals 0 is my solution, but what I write as my solution is that t lies between negative 1 2/5 and 3. That is my solution to that inequality. Now we're going to learn how to do that straight up using cases as well.